Welcome to this tutorial, Valve and Actuator Selection in HIT Portal. This example is for an air handling unit with cooling coil and reheating coil, with 2-port kVS valves. Here is the plant situation. In this plant, the cooling coil and reheating coil are each supplied with cold respectively warm water by their respective main pump. The main pump carries the water through the cooling coil, but in the case of the reheating coil, the pump on site ensures circulation through the reheating coil and the main pump returns the cooled water back to the generator. The control valve and the corresponding actuator for the cooling coil can very easily be selected in the Siemens HIT Portal. Click on Product Selection. Then, Valves and Actuators. Now you can choose whether you want to select the valve based on the present application, or whether you prefer to go to Direct Valve Selection. We choose Valve Selection based on application. Select Air Handling Unit. Now you arrive on the selection page for valves that are suitable for air handling units. The selection has already been restricted based on the application. Click on Calculation to correctly select the control valve based on the plant data. First, select the type of hydronic circuit. Select Throttling Circuit for the cooling coil. Now, a small graphic of the hydronic circuit is displayed, with its most important information. Click on Use Selected Circuit. This limits the list of possible control valves in the background to 2-port valves that are suitable for the circuit you have selected. Now, the volumetric flow that the valve must handle must be calculated. Click on the calculator symbol to enter the detail information. The volumetric flow is calculated using the power formula from the rated capacity and the applicable temperature difference. In this calculation, typical constant values for density ρ and specific heat capacity C are used. Here once again the plant schematic with the data for the cooling coil. The rated capacity of 75 kW can be entered directly. Now it needs to be considered which temperature difference is applicable for the valve selection. The cooling coil shall be supplied with water of 6 degrees, and the return temperature is 12 degrees. Therefore the applicable temperature difference for the valve selection is 6 Kelvin. Click OK. The volumetric flow has been calculated at 10.75 cubic meters per hour. Now it needs to be considered which resistance, delta PV100, the control valve must bring into the plant to achieve good controllability. Click on the calculator symbol to enter the required detail information. First, the pressure difference, delta PMV, in the piping sections with variable flow must be determined. It depends on the hydronic circuit, which piping section need to be considered. Here once again the graphic of the previously selected throttling circuit. The piping section with variable flow is highlighted accordingly. It is the piping section in which the water flow changes when the control valve changes its position. For the example, an experience value of 60 kPa is applied. Note that additional components, such as cold meters installed in this piping section, must also be considered. Such components often have high resistance values, which significantly affect the size of the valve. The calculation works by default with a valve authority PV of 0.5. The valve authority PV is the ratio of delta PV100 to delta PV100 plus delta PMV. With delta PV100 being the pressure drop across the fully opened valve at volumetric flow and delta PMV being the pressure drop in the piping section with variable flow. A valve authority PV of 0.5 means the pressure drop across the valve, delta PV100, is the same as the pressure drop in the piping section with variable flow, delta PMV. For this example, this means that a pressure drop across the valve of 60 kPa is aimed for. Click OK to take the entries over into the calculation. Based on the volumetric flow and the desired pressure difference across the valve, delta PV100, the calculated nominal flow kV is determined. This means the desired or ideal size or the ideal kVS value of the valve. The kV value, and also the kVS values, are standardized flow values at a pressure difference across the valve of 100 kPa or 1 bar. Click Accept. By doing so, the calculations are being finalized and the selection of applicable control valves will be further limited based on that. This select list can be further reduced. For that, select the desired or required valve parameters such as ports, connection and valve type. The selection is now limited to 3 applicable valves, and the order of this list is according to the previously selected application. In order to select a suitable valve, some additional information must be taken into account. These can be found, for example, in the data sheet or in the product brochure. The valve type VVG41 offers a stroke of 20 mm and an equal percentage characteristic. The valve type VVG44 operates with a stroke of 5.5 mm and a linear characteristic. The valve type VVP45 operates with a stroke of 5.5 mm and also has a linear characteristic in this size. If you select the pencil symbol, you can choose a different size, that means a different kVS value, if required. In this list you can see the effective resistance delta PV100 and the associated valve authority PV a different valve size would have. In our example, the next smaller size with kVS equal to 10 cubic meters per hour would already have a much greater resistance, and thus an even greater valve authority. We therefore accept the proposed size with a kVS of 16 cubic meters per hour. We select the valve VVG 41.32-16 with its equal percentage characteristic, because this is suitable for a cooling coil. Why this characteristic is suitable will be explained now. A typical cooling coil has a heat exchanger characteristic that is highly nonlinear. This means that even at a low volume flow, a relatively large amount of power is transferred. An equal percentage valve characteristic, including taking into account the influence of the valve authority PV, largely compensates for the nonlinear behavior of the cooling coil. Thus, the combination of cooling coil and equal percentage valve characteristic results in a controlled system characteristic, with a fairly even behavior between valve stroke and transferred power. This provides a solid basis for controlling the cooling coil. Now, select the appropriate actuator for this valve. Here, a select list of suitable actuators is also provided. Now the desired parameters for the actuator must be provided, such as positioning signal, 0 to 10 volt, operating voltage, 24 volts, positioning time, medium, that means 30 seconds, and so on. The selection is now limited to 2 suitable actuators. The actuator, SAX61.03, is being selected, and with that the valve and actuator selection is completed. This selection of valve and actuator can now be added to the cart. Or if there are many valves to be selected, this selection can be added to a project. For the reheating coil the approach is identical to the cooling coil. First, select the type of hydronic circuit. Select injection circuit with 2-port valve for the reheating coil. Click on Use selected circuit. Here once again the plant schematic with the data for the reheating coil. For the calculation of the volumetric flow, the rated capacity and the temperature difference are needed. The rated capacity of 65 kW can be entered directly. Now it needs to be considered which temperature difference is applicable for the valve selection. The reheating coil requires a supply temperature of 50 degrees. The boiler provides a supply temperature of 55 degrees. And the return temperature from the reheating coil is 35 degrees. Therefore the applicable temperature difference for the valve selection is 20 Kelvin. Click OK. Based on the volumetric flow calculation with this temperature difference and a desired delta PV 100 of 15 kPa, a list with 3 suitable valves results. Based on the same considerations as applied for the cooling coil, a valve type VVG41 is also being selected, with a nominal diameter of 20 and a kVS value of 6.3 cubic meters per hour. The effective pressure drop across the valve, delta PV 100, is 19.68 kPa, resulting in an effective valve authority PV of 0.57. Additionally, a suitable actuator is being selected with the same parameters as for the cooling coil. Now the control valve and the actuator for the reheating coil are selected. They can also be added to the cart or a project. In summary, here once again the most important aspects to be considered when selecting a valve. Which hydronic circuits are used, and what are the consumer's performance data? Pay attention to the correct temperature difference for the volumetric flow determination, that means. What temperature does the generator supply? What return temperature comes from the consumer? Identify the piping section with variable flow correctly depending on the hydronic circuit, and determine the corresponding pressure difference delta PMV. The valve authority PV should be equal to or greater than 0.5, or in other words delta PV 100 should be equal to or greater than delta PMV. The valve characteristic should be selected to match the behavior of the heat exchanger. In summary, here are the selected valves and actuators for the cooling coil and the reheating coil. Thank you very much for your attention.